Well, I'm here to hopefully redo some of these cross-section notes so it's a bit clearer for you to see what I'm actually doing. So hopefully you guys are doing well. Um, we don't know exactly what's going to go on just yet, but we'll just kind of make do with what we have. In terms of volumes of cross-sections, volume is how much space something takes up. And what we're going to do is we're going to calculate that volume with these slices of shapes that are all the same. So like squares or triangles, semicircles, that kind of thing. And then from there, we'll be able to make a volume by adding up all of those slices, all of those squares together. So think of it like a loaf of bread. And we're going to calculate the area and volume of each slice and then add up all those slices using our integral. Okay, so to start us off first, we're going to have to find the area of our slices. And so these are the common shapes you'll see here. So for example, a square, it's going to have, like if this was S, this would be S, and so we'll call it S squared. One of the things that we want to kind of note is, so the area is equal to S squared. What we want to try to do is we want to try to create the area of each of these shapes based on a reference length. And our reference length is going to be called S. And S is the part of the shape that touches, I guess, the ground, and it's going to grow up from it. So if you watch some of the other videos before of me showing you kind of like the graph paper, the diagrams, or some of the other videos that I'll post soon, you want to make sure that you see that these are growing out of the ground. And so where the shape, where this slice touches the ground is S. So for right here, for example, this is the part that would touch the ground. We'll call this S. And so the area for this one will be equal to, okay, if you do some, like geometry, you'll see that it's going to be square root 3 over 4 S squared. Okay, same thing with a semicircle. The semicircle over here is going to be, this whole thing is S. Okay, but what we want to realize is we only want the radius, okay, to calculate the area of the semicircle. So the area of a semicircle is area equals 1/2 pi r squared, because that's all we really need. Okay, we only need half the circle. But r is equal to, and since this whole diameter is S, r is going to be 1/2 S. So when we put that in there, we're going to get something like 1/2 pi parentheses 1/2 S squared. So you'll notice I replaced the r with 1/2 S. Now we calculate all this stuff out. This needs to be parentheses because it's going to be 1/2 S times 1/2 S. So it makes 1/4 S squared times another half will make 1/8 pi S squared. So that takes care of the first three kind of basic shapes. Let's move down to the last few. Okay, now we're going to get to the circle part. So the same thing. The area on this hand, let's see, area is equal to pi r squared. Remember, this whole thing is S again. Okay. Now we could do all of this. We could show you all the calculations. It's very similar to the semicircle. So we've already done that. So it's like two semicircles. So we'll take our formula from the semicircle, 1/8 pi S squared times 2, because you want two of them. And so we'll get an overall 1/4 pi S squared. Let me rewrite that. Okay. S squared. All right. So there you go. For the isosceles triangles, it depends. Isosceles, remember, just means two sides that are the same. The only difference is it depends on which side is actually touching the ground. And so in this example, we're going to say that this part, one of the sides that are the same, touches the ground. So we'll call it S. And so the area here would be 1/2 base times height. And this is S, this is S. So this will be 1/2 S squared. Okay, easy enough. All right, down here, for this one's going to be S, but this is the hypotenuse. And so we know that this triangle, okay, if you pretend that this is the base, this is the height, if we just call it A, for example, A and A, we know that this triangle would be 1/2 A squared. Okay, so 1/2 A squared is the area. So how do we figure out it in terms of S though? Okay, so we have to use the Pythagorean theorem. So we have A squared plus A squared equals S squared. We have 2A squared equals S squared. And then all we do is we get A squared by itself. A squared will equal 1/2 S squared. Does that make sense? Okay. And so what we do then, let me just change the color here for a sec. What we do then is we take this and we replace the A squared with what it's equal to. And so we end up with 1/2 times 1/2 S squared, which will equal 1/4 S squared. You're going to notice that for all of these area formulas, it will always be S squared, which is the great thing. Okay, so it'll always be S squared. The only difference is the number that goes in front. Okay, so whatever the number is, like 1/2, pi times 1/4, that kind of thing, it'll always be S squared. It just, depending on the shape, the number, the coefficient in front will be a little different. Okay, so that's page 1.